Hello, today we will look to the FMH3, which is another elementary microwave NDT sensor. This is Arduino based and can be used for diverse applications. The sensor consists of a small test head and an electronics box. The sensor is to be moved over the surface of the device under test, either by hand or by a scanner or by a robot. The test head, by a flexible cable, is connected to the electronics box, which contains an Arduino mini computer. This is accessible to the user. He can program it through his computer, which is connected to the Arduino by a serial USB port. This computer with a proper code can also be used to further evaluate the detected signal. This can be done either for a simple display of the momentary reflection coefficient at the input of the test head, or for data storage, or for a combination with the location data generated by another device. It is up to the user to generate a code up to his purposes. In the following, we will see a rather simple application, namely the display of the momentary reflection coefficient in the XY plane or complex plane. This is the microwave instrument FMH3. It consists of a microwave module with the sensitive plane being this here, and an electronic module which makes the pre-processing of the signal, so then it can be displayed directly on a computer. In this case, we have connected it to a laptop, and we can see the dot in this case being in the middle of the display. And we can also see that this dot moves if we change something before the sensitive area. The electronic module has possibilities to change the offset of the signal and the amplification of the signal, and that for the horizontal and that for the vertical displacement. In the following, we make a small experiment, and then I will show the display in an insert. First, let's look at the sensor being approaching a metal plate. We see that there is some spiral, circle with increasing radius, and now outside the screen here. And we move from the plane, metal plane again, and the radius becomes smaller and smaller. That's the typical behavior when approaching such a surface. Well, this metal plate is a very big reflector, and now we will look to smaller reflectors which are inserted into this piece of 30 millimeter thick glass fiber reinforced plastic. When we place it onto the surface, we have some offset against the placement in air, and we can change this with the offset here in our electronics module. That's the one. And well, we have some small artificial defects here. The one is this, and a very small hook only. And we can increase this by more amplification. And I will do that here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That was for a horizontal display, and now also for the vertical one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we can correct for the offset. So then let's take some ruler here for a better movement, to have a better movement of the sensor. Now we take it along here. And we see a big indication here at this place. And it's quiet again. And another indication here in this place that was now increased, that one which we had seen before. Okay, let's see what's behind these deflections. Well, the one is a very small dent in the surface, and the second one is a blind hole from below, from the bottom. There are some two defects which could be seen by this FMH3. Please keep in mind that this is one of the most simple applications of the FMH3. The system can be used for many further applications of microwave testing. It is open to the user to adapt it according to his needs by programming the Arduino code and the laptop or PC code. Thank you for watching. See you next time. Goodbye.